Hello, everyone. Hello, hello, hello. Hello, Viari. Well, now it's on, right? I was just a bit delayed there. Yeah, should be on now. Close this. I have only one screen currently, which makes streaming a bit funny, because you have all these things where you can see the stream stuff. So let's do like that, maybe. We just minimize OBS. Choom, like that. Cool. Like that. So, some Karl2D audio programming, right? Yeah, that's what we're doing today. I haven't been streaming much, long time, but I have more time recently, so we can do more streams. So, let's close the window. Like that. There was a truck driving past. So, I think I'm in the middle of some refactoring. Yeah, let's just undo some stuff here. This doesn't matter. We'll see. We can discuss what I was doing here. Maybe I'm just gonna undo like a bunch of stuff here. La 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 la. See where we are. Now it should work, I think. Maybe. Oh, let's see how the desktop audio is off. Do 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 do. This might be some funny sounds here now. This is gonna be a lot of this. If you don't like sounds, this is not the correct stream, because we're gonna test sounds. But do let me know if it's too loud, the desktop audio. So it's playing some music from Cat and Onion as a music stream. And I can change the pitch of that up and down, stop it, make it play again. And such. See, maybe it's a bit too low even. Yeah, that's good. So that's my little music demo. It's not much right now. If we look in the audio file here, this is an audio example file I have. Here we have it sort of loads sounds and makes sine waves and loads music and stuff. And there's also a looping, so we can turn off the music actually, like this, I think. And then instead play a sine wave. Classic. Check the volume on that. Yeah, I realize might be good to have a second screen for this kind of stuff, but yeah, I don't have it currently. I can change the pan. I don't know if that comes out on the stream of playing audio, but there's a difference here, right? I can change the volume of it. This is just using these instructions here. There's a difference here, right, between the sound, the continuously playing sine wave here, which was this one, play sound SND, which is a sine wave of 200 hertz, at least half a second long, and 44.1 sampled, 44.1 thousand samples per second. So we have a couple different sounds. They had this silly, I think this might be from Lemmings or something. And then we have a music track that I disabled playing of. The music track is a stream, which is something I just merged yesterday into the library. So this is my 2D game creation library, by the way. Yeah. But yeah, so we're gonna do some more work here. Yeah, happy Friday. I was so all the audio support in this library, right? So I tried to make it, you know, so that it uses a few dependencies and stuff. So I've written my own audio, my software mixer, kind of. So instead of, like, if you look at the Windows wave out backend, then it looks like this. I like this chaos here. Maybe. Oh yeah, you can't see that because I realized there was you could see my desktop behind my portrait here with lots of weird files. Nothing incriminating, but I was like, there's a hotel for PDF about a hotel in China. But then I realized that there was my picture was there. I like down in the bottom right corner. I can see my desktop, but you can't. Anyways. What was I saying? Yeah, the wave out backend is here, and it's not big, as you see. This is the whole thing on Windows. This is all the Windows specific code for playing the audio, and it just, you know, sets up audio wave out open, blah blah blah, to open the sort of audio device, and then you feed it samples like this, and you just feed it all stereo samples. They come in as 42-bit. Floating point numbers. Like an audio sample is just a F32, right? It's between -1 and 1. So the backend is very simple because I do a software mixer. Like if you can, there's also this high-level audio APIs and stuff you can use, but those tend to, you know, things might sound a bit different on different platforms because they don't mix it exactly the same, a bit hard to control, a bit boring. Like it becomes a lot about, you know, setting up like a new platform means set up a new, like use a new API in a million different ways, like set the pan, set the pitch, set the volume, and then control the playback in a certain way. Here I just control how it's put into the software mixer that I write myself, and then I just take the mix stuff and throw it to the backend, and it's done. And then I can just add, like if we look at the Mac Core Audio, I think it's called. This is the Max one. This is, you know, it's not a lot either. It's like 130 lines plus some binding to some library maybe somewhere. Like I have in here platform bindings. We have Core Audio and Audio Toolbox, because those don't exist in the like in the vendor or core libraries of Odin. So yeah, very simple everything. So we can look at the what I was doing some work on the mixer just now. That's what we're doing. So we were we're solving a bug actually. Let me see if I can bring up a web browser here. github.com. We're solving a bug in here. Issues. It's this one. Mono sounds play at double speed. Originally this had some other name, this issue, but essentially I didn't have mono support because I had just programmed it for stereo only for some reason. I thought I'd fix that later, so I've tried to fix it yesterday. What this one is just saying is that the sound sounds weird first before there was on Mac, but it realized, oh, there was a mono sound, and then the funny thing that happens is I interpreted it as a stereo sound. Then the mono sound just became like, it just took, instead of taking, you know, one sample and then the next and putting it out for both speakers, it took one sample through left and one through right. So it just played a double speed because it just had half as many samples. So it just was like a 2x pitch, essentially. So I started working on that yesterday. So I have support for mono sources here. Yeah, it's a bit of work, because what happened was essentially that load sound from bytes here. This is my own little wave loader. I don't support any other formats for the sounds. For the streamed audio, which is like music, for that I support Og Vorbis right now. maybe I support wave as well. But yeah, so I this is just some commented out extra stuff that I haven't used from the WAV header. But micro WAV, WAV is a funny pronunciation. So I didn't have this yesterday. This I added so it actually fetches the number of channels from the header of the wave file. So it gets mono or stereo depending on what this one says. I don't support, like, it's a sort of opinionated thing. I don't think if you're making a 2D games you will ever need anything else than mono and stereo sounds. You can come up with examples if you want why I would need that, but either it's like mono sounds for if you want positional sounds, or just, you know, sounds that you can happen at one place. A lot of sound effects are mono sounds. They can happen in one place and you sort of place them based on, like, relative to the player's position. Maybe you pan them a bit, but they're mono sound. And then you have some stereo sounds. Quite often music is stereo, but that's not used loaded by this. That's loaded by Vorbis. Right. So I added this thing yesterday, right? My band's mixer record show us in a 32 channel. Records or shows in a 32 channel WAV file. Wow. Oh yeah, that's good. That's nice, because then you can get you can pick out the channel separately later, right? You would think that they would use like some fancy format, like, I don't know, you know, some fancy proprietary mixer format that's like, oh, here are all channels, and you're like, no, we just pretend you have 32 speakers and go. Oh well, that's not really what channels are, but that's how they're usually used in this kind of case, right? It's like either mono or stereo. Nice. Yeah, that's yeah, 42 channel. I guess they support. I wonder what the channel is a 16-bit number, so maybe it supports up to 16. What is that? Is it 65,000 channels? Let's make a mixer board with 65,000 like little things for controlling the volume on each channel. Very wide mixer board. Hello Barnum and Chris. Chris PHP also has a nice YouTube channel that I watch sometimes. Welcome. Anyway, so I grabbed out the channels here, right? Mono stereo. So I did that, and then I throw that into the load sound from bytes raw. This is the sort of thing that takes just a byte array and a source format and a channel and a sample rate and sort of assembles the thing. You can use this. This is what I use to make my own sine waves. But yeah, this is what I use to make my own sine waves. But so here I both look at the format, like is the format we get, is it like floats, or is it integers? And then we need to convert everything to the same format. I use floats for everything, so we just convert it to floats. You know, we kind of divide. If it's integers, maybe we divide by the maximum I32 in the case of integer 42. But the channels, I don't really care about the channels here that much. You see, channels is just piped through here, so it just takes the samples and then pipes on the channels to the audio buffer here that it makes. And the idea there is that I save resolving the channels until the mixing. Well, there's two ways you could do this. Like if you want to, if you support stereo and you want to add mono support, you could take the mono sound and expand it. So you take, you store your internal audio that's internal in the library, the sort of audio buffer. You store that as stereo always and expand it, so you copy it to left and right. But that, then it will take double the amount of memory for each sound and stuff. Feels a bit wasteful. So I just save the channels here. So then later when we mix, and this is what I was just working on right now. Later when we mix, we say, is it mono or stereo? And you get all the source samples here. There's just an array of F32 essentially. The destination here is the mixer buffer. That one is always stereo. So it's an array of two, like one left and right. The first one is left, the second one is right. But the source here is just an array of samples, and we interpret it in here depending on which one it is. So this audio mix here is called, it's called here, you know, here is this whole procedure is the this is the update audio mixer here. So here we have an out buffer, which is the mix buffer. We're gonna write into that one. We're gonna write this many samples, which is like 1,400 per sample pass roughly. And then down here somewhere we say that here we use mix. We say, oh, take these. Here's the source stuff. These are the source samples from the data, and this is the mixer buffer, and here are the, take that many, and then, you know, we get the channels here as well. So, you know, then we just need to figure out, like, is it mono stereo, mono interpolate, or stereo interpolate? And the thing here is if interpolate means that for example the pitch or the bit rate, is that the correct? Not the bit rate. The pitch or the sample rate is not, the pitch is not 1, or the sample rate is not the same as our internal mixer. Then we need to like fill in the gaps in the, you know, make new samples by interpolating between them. So essentially, if your buffer is at, you know, if you want these samples, well, maybe you can make a wave instead. If you want samples like that, but well, how do you actually write this? Anyways, if you want this many samples, but you only have this many samples, then, you know, the one in between here, you must interpolate by taking this one and sort of so imagine that the sample rate is lower for the playing sound, and you want to mix that into a higher sample rate, then that's what happens. Right. So that's what I'm doing here. I throw everything in here, and then I sort of, this will mix one playing audio buffer into the mixer buffer, and it will do it. So it's sort of like, you can think of this as it wants to mix in 1,400 samples essentially per mixer pass. So it does that, takes 1,400 samples from the source, the data, and mixes it in. So in mono, it's quite simple. Mono, no interpolation, super easy. Well, the sound device might be in 48K, but you can usually tell when we make the wave out device. I always make all my devices I make in 44. I make the audio device in the back end. So far I haven't seen one that can do 44.1 thousand samples per second with 32-bit floats, 2 channels. All backends I've made so far, which is Mac, Core Audio, Wave out on Windows, ALSA on Linux, and Web Audio. All of them do that. So I never have the 48K problem in the mixer. What could happen is that you get a 48K sound playing, but your mixer is running at 44.1K. But then it will just skip some samples. That is sort of it's not interpolation, then it's sort of, you know, I think that's how it works. I haven't actually tested that. I have never had a 48K. I can just render out one day from Reaper or something, and we'll see. But yeah, mixing in like 1,400 samples, N samples in mono is very simple. You know, you take the volume and the pan and you multiply, because the destination is in stereo, right? So X is left, Y is right. I don't know. I just use this. I could do this also, you know, but for some reason I just used X and Y. And then I just grab the sample. Easy. And then we lerp the volume and the pan here, because that's it. Since it's mixing a bunch of samples, it needs to interpolate the volume and the pan so you don't get discontinuities, because then it will pop. There's an interesting thing here about audio, right? that some people don't realize, that audio is like a wave. Like this is essentially a sine or a cosine wave, and the reason this makes sound, it like a common issue you do, like when you make your audio code for the first time, is that, okay, I'm gonna try playing a sound. So then you just try to put in like, I put in 0.5. Like say that your audio goes between 1 and -1. So you try to put in 0.5 like constantly, like this. Say that you do lots of samples that are at that have that sample number in the sample, and you're like, oh, I don't hear anything. Why? Well, it's because samples is just like, it's the difference between one sample to the next that makes the speaker move, and that produces a sound because it pushes air, right? So if you keep it at a constant position, it doesn't make any sound at all. It just, the speaker is initially at one position, and then you just told it to move out and then stay there. That's essentially what it did, and it stays there. So that's why, when you have a some kind of what is this, a cosine wave like this, then it makes a sound because it's continuously moving in a pattern like this, and it doesn't go ooh. No, that's not what it's doing. It's just, it moves in a smooth manner that makes the speaker constantly move in such a way that it produces a constant kind of, just a constant note, a single note. So it can be a bit confusing when you look at this for the first time, because you could think that that's why we need to interpolate the volume, because if your sound is like this, and then you increase the volume so it suddenly jumps to like this, then this gap between here and here happens over one frame. That is like, infinity derivative infinite kind of just hops up a lot, and that will just go like a loud pop in the speaker, because the speaker just boom moves to that position. So it's not so good. So it's a bit annoying to change. Well, it's more annoying than you think to change volume of a playing sound. Like set sound volume. You're like, okay, what I do then, now this is a tangent, set sound volume, I'm like, okay, then I say, if this sound is already playing somewhere, then on that playing sound I set the target setting, I set the volume, and the target settings is not the final settings, obviously from the name. So while it's mixing, it's actually fetching the target settings for, here we go over all the playing audio buffers. It fetches target settings, and then it's sort of like the volume starts at the current volume, and then we wanted to move towards the target volume with some parameter based on the pitch and many things. And then we get the start and the end, and we get the start and the end also because we're mixing 1400 samples, so we can't just like get the volume at the start or the end of that range. We need to like smoothly move the volume properly throughout that range of samples, and we also need to move the volume quickly enough so that it doesn't feel like it's like, it essentially happens within I think it happens within a few milliseconds, that it can move from -1, from 0 to 1 essentially, if you need to. But it still needs to happen a bit smoothly. It can't happen instantly. Well, it could. Maybe there should be a function that does that, but it won't be nice in your game. Unless you yourself do the interpolation where you kind of do all this work. But anyways. So that's why it says lerp here, from start to end with T. Because it's that it knows that for this number of sample it's gonna mix in, it's gonna go from this volume to this volume, and then T is just how far have we gotten through all those samples. We mix those in. That's easy for mono. For stereo, it's also easy, kind of. We reinterpret the source as stereo. I just do this. This thing here is, and a slice of audio samples. I use reinterpret as with a 2. I know that it's gonna be an even number, so it's gonna be fine, but but yeah. So I just do that, and then this code is actually the same, except that this part only, this does use array programming to just like add the whole sample, both left and right at once. You just multiply by pan and volume. What is to, you can note here that this code looks very similar, and you think that, oh, can't you like deduplicate this? This probably won't change much. So like making it, you know, trying to make like some kind of thing that has, trying to make it so that it, you know, it's there's only one code path, like there's only one function, a generic function, is probably not worth it. And you don't want to make an if in here, because this is a tight loop, and if you do an if, then it can't optimize it, because these things will probably get, if you turn on optimization, like, you know, in the Odin compiler, this might get vectorized. If it doesn't, then I'll have to look at that someday to use SIMD and stuff, but this might just get very fast on its own. So that's mono and stereo, and then interpolate is tricky, because then suddenly you need to, that's what the stuff I talked about before, where you, this is not the interpolation of the volume, it's the interpolation of if the sample rates differ, right? So then you need to instead be like, what's the previous sample value and the current one in the source, and then we need to take out the sort of, wait, what to do here? Yeah, here down here we lerp. So we have sort of a little fraction here that it says how far between those we should go. We have to do that. So that becomes a bit more tricky. But this makes sure that samples of, like, for example, 22.05 thousand samples per second gets mixed up to 44.1. Or in the case you listen to this thing here, this was actually from the bug report I got on GitHub. That sound is like, it's like 8-bit, 8,000 samples per second. It's like super low. It's a super lo-fi sound, and this was the one that not the sine wave that's playing, but the one that one I got from the GitHub issue. Thank you to Moomerman who sent me that. But also it's yeah, that one played at double speed because it was mono. So it's mono, 8,000 samples per second, and I think an 8-bit sound. So it was quite good to test with. I rewrote this a bit yesterday because I had like lots of I had like 2 different mix functions, one for interpolation and one for non-interpolation. But since I need to use this twice also, it gets a bit messy here because I mix it, right? And then this, maybe I could move away out of here. But then I need to check, like, did we actually mix everything? Because the sound might have looped. And then it can't mix everything because it got to the end. So in that case, it will do some more. I could perhaps make this one aware of the sound itself and do that. I'm not sure. This works for now. Just at the start of the stream, I was trying to put this stuff here because it's repeated down here. I was trying to put that into the mix function, but yeah, it's not really worth it right now, I realize. So we have a little pull request going with all this stuff in it. This is this pull request. So we should try to get this in, because this adds support for mono sounds, essentially. Let's just look through this and see that we're happy with it. So we can see what we've done. What we'll do actually is this. What I like doing, I like looking at myself, and then I also tell this GitHub Copilot to do a PR review of this. Just write the summary here. Summary here. And then not that one. Just let it do that while and then sometimes it just catches some other things that I don't see. Anyways, so Claude review this PR, yeah, kind of. So we've changed the audio backend so that it always like audio sample used to be a stereo sample always. I changed that so that it became an F32. What do you want? Okay. So that it became just an F32, and then so add in 2 here whenever I want stereo. I don't know if that is the best way. I think it's the best way to pay based on this PR. So we do that. Actually, have I even committed everything there? No. Well, actually I have. Yes, good. I was checking so this funny AI didn't look at the wrong code. And then we look through, what's this? Audio stream default. Oh yeah, this is to get mono and stereo sound support in the playing music. And then we make a buffer for the playing music. For streaming audio, actually the buffers is used sort of like a circular buffer to put stuff into, rather than it uses the same thing. It just, the playing music is an audio buffer that is just updated from the stream. So it's just a short audio buffer that's used in a circular way. So it just flushes more and more stuff into it. And then this is also in the audio stream stuff. I don't know if this is the best way to do it, but it fetches left and right channels, or the mono channel. And then it's, what's this stuff? Oh yeah, this is in NumChannel. Oh, this is the stuff that extracts from the WAV file, and then it feeds that into bytes raw, and then it does that. And then here you see that everything here used to be 2 samples, because it was always stereoing before, but now it just takes the sample straight away and just passes on the channels instead. And then we've collapsed all these. In the past we had add and add interpolate. We've collapsed it all into just audio mix. And that I showed it. There's no does all the mono interpolate blah blah blah. And then we just use the new audio mix stuff. And then yeah, this here you see how I changed audio sample. Here's just an F32 now. I have a new concept of mono and stereo, the channels on the thing, and then I've changed the mix buffer. It was also 1 megabyte of samples. That was quite intense. So I changed it so that it's 10 chunks. I choose a number. 10 chunks. That's like, essentially, I think that should be fine. I don't think it ever will use more than like 3 or 4 chunks. Like that's 1,400 samples. So this is like 56,000 samples. I didn't do that math just now. I remembered it from before. I'm not super Jesus. Right. So let's see. That all looks fine to me. Let's see what this. Oh, you're not done yet. What are you doing? What the hell is a work tree? Okay, Screw you, Mr. AI. It usually works fine. It can catch some stuff, but now we're just doing random stuff instead. I don't have patience with those kind of things. If it doesn't work, I even wrote a silly agent thing for it so it could figure things out better, but whatever. I just wanted it to look at a diff and see like, it's good. Right. I'll remove that let's go thingy because it is I already have another sound there. Aha, yeah, it has never done that before. It's never talked about a work tree ever before. I feel that those kind of things, like these AI things, they always like they run into something and then they use a new random method for solving it. Because they're sort of stochastic in a way. They're like, oh, today I'm doing this way. I'm like, oh, are you now? I've never seen that before. Prompt engineering. Yeah, I'm not a very good prompt engineer. I just use them for. They're good for doing pull request reviews, for finding like things you messed up. Okay. Let's try it. Like, let's click this. Allow. Okay. Since I know what it does now, see if it can give me the blah 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 push location. You don't need to build the thing. I just want to look at the code. I didn't instruct it well enough, but it can do that if you want. Push location, git diff. Yes, that's the part. That was the important part. Just make a diff, look at the diff, tell me what you think. So we're gonna remove this. I like confusing the AI by editing the file also. Oh, is it now? I don't know, you made the folder. First time ever I use anything AI on a stream and it's just throwing me random curveballs. Oh, anyways, we're gonna use that one. I'm rage baiting the AI. Yeah, it's listening to microphone and just it's trolling me, isn't it? Maybe if we do this, music file is this one. No, you see, it has gotten completely confused. I'm gonna click this. We'll redo that later. Whatever. Got annoyed. Oh, thank you, B. Sherman. Maybe it's pronounced. Thank you for watching. Has music. So the reason I'm doing this is I don't want to upload this big OGG file because I love when the repository is small, and it's very slippery slope to start throwing in big binary things everywhere. So we're gonna do this, else we just play this looping nice sound. Maybe I'll make a little UI for this sometime, where you can like select files from a disk or something, like a little. Maybe I should make a little Winamp. And down here we have some music stuff. When has music. Was there an if up there or a when? It doesn't really matter in this case, but whatever. Since we have a compile time constant in this case, we can do that. Music pitch. Those guys we put in here. The reason I'm doing this is just because otherwise I don't want the music to go all crazy. Why is this one like before the update? Or just a special? Just need to have. So I'm doing this sort of raylib thing, where you have to update the music stream manually. So for each, like you probably don't have that many anyway, so it's not a big deal to do that. But you have this music stream app. Oh yeah, and also split out the audio stream stuff to a separate file because of web. The currently doesn't work on web because I need to do some extra work to get it done. And yeah, so it's just in a separate file right now. So the music stream update, what it sort of does is take the playing audio buffer and the audio buffer, and then it also has all the Vorbis stuff. Well, yes, I can get to why it can't be updated automatically, the music stream that is. It could in theory, but there is some subtle things here. So you have the audio stream here, and then you have the Vorbis stuff that's decoding stuff, and it's sort of putting it on the buffers. This is the audio buffer.samples. It's sort of writing them in here. Here is stereo, here is mono. Right. So it does that. That's what the update does. The reason I do this manually is because what an audio stream essentially is a bridge. Hello, welcome. It's essentially a bridge between an audio buffer, well, an audio stream and a buffer, right? And there's no natural place in my code, in the library sort of, where I can do this. Well, maybe I could do it like in update here, but that update everyone might not run that. I could do it maybe in the mixer, but if the mixer starts going to disk and streaming things in, is like, and you can't control that, is that really what you want? Sometimes you want to, if you want, currently, if you grab the window handle and move it around, the music stops. Maybe you want to move it to a thread, and you want, but the mixing maybe you want to keep on the main thread, but you want to update the music on a thread so that it doesn't stop when you move the. In that case, you have a problem there as well. So essentially, I need to make the updating of audio streams, reading from disk, streaming it in, putting it into a buffer. To make that happen automatically, I need to keep track of it, and it needs to be done in a very specific place. But maybe I'll add it at some point. I'm not sure. I've tried to put it in somewhere, and it didn't make sense. And when doing these kind of things, a lot of the design decisions that maybe Ray did for Raylib sort of like they seem random when you're just using it. Like, oh, why is music? Why do you need to do update music in Raylib? Why doesn't it just play? Maybe it's a similar thing because it streams from disk, and when is that supposed to happen, and how does it work? Like, how does it interact? Like, Raylib is known for being like, many people don't use threading too much, but updating your music is actually one thing that you often do on a thread. I did that for Cat and Onion. That's the game is just one thread, except that it updates the music. It runs rl.update music on a thread and then sleeps for 10 milliseconds. Because otherwise, if you get a frame stall or you move the window around, then it just stops. So we have that update audio music stream, right? Yeah, you can get little stutter. It depends a bit on how your game is set up. Like how long the frame is, when does vertical sync happen, is VSync on, how long refresh rate is it, how long refresh rate. That was that those units did not check out. Right, so what I was doing here was just doing this. So that plays. And if I then wait, can I do like, maybe I just oh, I don't have, yeah, no, whatever, yeah, let's just keep it like that and just remove the well, you don't need to remove the file because it's in the bin folder, but yeah, we'll just do like that. And then if I go here, reveal in File Explorer. It's quite scary with Git actually. Because if you add something to the repository, then it's there, and then you can't just force push it because you will break people's history, right? So it's a bit scary. So what I was gonna do here was just cat and onion, remove that, and see if it's instead plays a looping sine wave. No? Oh wait, because it does not exist. That's just if this path is set. Oh. Let's just do it like that for now. Then it plays their funny sound. Oh, maybe we can do this. If it's let's put it the file back. Let's do this nicely, maybe. Let's do like this. If has music. Then we do this. K2.set audio stream pan. Set audio stream pitch. Is that what we want? No. Because, well, okay, I have a we have multiple things here going on. Music pitch, but then we have, where is the sound pitch? Where are you from? Where are you from? There it is, sound pan. So these three, I either want them for like this. Looping sound. Let's just call them like that, whatever. This whole demo is gonna be remade. I just wanted the instructions to make sense. So you can remove this then. That one is good to have, the stop and start. And then we just say SND pitch. And here we say set audio stream volume. So what I'm just doing is what I'm just doing is making sure that we get either or here. Let's take these guys. What's this? Play sound. Right, so we can just maybe move this down here instead. Throw this in here. Now I can. Yes. Yeah, you can change the volume, and this changes the playing audio, the playing music now instead. There's something funny about the first time the pitch change works. Yeah. And if we remove that thing, we should play a do. We have our good. Yeah, good. Woo. It's quite cool, you know, with the software mixing, because I had some bugs in the mixer that produced the bad noise, and then that same bug was on all the platforms, the identical bug. That's with audio. Often you get, you know, different bugs in different platforms because of different APIs. But with software mixing, I had like the same audio bug on web and Windows. That sounded like it was sort of like a low-level bug, but it was just in the mixing. So that works good. What I was gonna do here is just change maybe this. We just do this. Playing label. No. When has music? Yeah, sure. That's fine. Then we do that, and we go here, and we say playing label. We tried that. Playing a 200 hertz sine wave. Wow! And then we go up here. Oh, and we put cat and onion.og. Yeah. Good. There's a funny thing with Odin that the only time you can use it's not. I know exactly why this is like this, but people get confused by this. The only time you can use plus to add strings is when both are constants, because then you can do it at compile time, and you can just take this stuff here, music file, which is a constant, and put it together with this one, because, you know, there's no manual memory management required to manage that new string. It can be done at compile time. You can just concatenate them at compile time. But actually, I think I programmed Odin for quite a while before I ever even realized there was a plus. I think I used to like, oh, I need to combine two strings, even if they're constants. I kind of used temp print stuff. So now that works. So we'll just comment this. This is not the best way to do it, but I will just redo this sample another time. So we just do it like that. I would like to have a little, like, you know, it sort of looks on the disk, and it lets you select stuff instead. But yeah, that's fine. What have we done here? You can look in this. We remove the, I think it's from Lemmings, that sound. We changed this one a bit. That's good. And then this random shit that the AI did, that work tree thingy that we removed. And here I just removed a dead comment, essentially. Right. You may notice that I'm in Visual Studio Code instead of Sublime. I used to use Sublime. I tried to use Z. Z is a bit it's nice, but it has too many bugs. I don't like it. But it's like VS Code, but not made using web technology. So good. But it has too many bugs right now. I can't use it. Let's just remove this one, because the audio is sort of getting there. There was a comment at the top that says, don't use it. But yeah. But yeah, no, I use VS Code because I mean, I do use the little AI thing for doing code reviews and just looking things up sometimes. And that is handy. And that doesn't work in Sublime. So I've actually, for that reason, and also that I get a built-in debugger. You know, if I press F5, I always debug. That's quite good. Yeah, Z is fun but immature. That's yes. It's just like it works and for a while, and then you're like, well, maybe not. Well, because then you're like, I currently have a bug in Z where when I press the button to compile and run in debug mode, you know, you're supposed to compile my project and I start the debugger. The one's supposed to rerun the most recently used one. In some projects it works, but in one project, in this project, if I use it in Z, it just picks a random project each time. It's supposed, like, it that works in other projects. In that project, it just picks the wrong project. So I'm like, oh well, I want F5 to compile and run my project, and like weird stuff like F5, when you press F5 to compile and run, it doesn't actually save. Like if I have an unsaved file, I'm like, That's all editors do that. If you press compile button, if it's in your workspace, the file should be saved. Because I always like, oh, that did nothing happen. Oh, I didn't save the file. So and then I had to like manually set up change that key binding, and that wasn't easy either to make it work. But anyways, update. Oh yeah, this thing about this putting in files into the this thing about putting in files like this. As long as you do it on a branch, on a pull request, you do a squash merge. Then even if you put in something large and then later delete it, then it's fine. But if you merge it, in a non-squashed mode to get the history, then then your repository will have grown because it has the history of that file having existed in your repository. Oh, but this is not a big file, so I'm not sure. I thought about the song, but that song is not in one of the checked in folders, so whatever. Update audio example. Something like that. Yeah. Go. Let's go back to our pull request. This doesn't need to be drafted anymore, I think. Oh yeah, I also need to update projects Karl2D Odin run tools API doc builder. Here you can see what I changed in the API. I changed byte raw. I mean, the doc file is generated, but it's also used as, what I do is the pull request will fail unless it tries to regenerate the doc file, but unless it matches the one it generates during the checks, unless it matches, it fails. And the reason it does that is, well, I can show you why it's important. Git commit docs. You push that. The reason, so this would currently fail because it would try to generate the doc file from this file and it wouldn't match the one that's currently in the repository, right? I think I've talked about this before, but so this file is here, right? And we do this because then the person making the pull request will see this doc file when they generate it, and you get a good overview of all the API changes you've made. So you look at it and you be like, oh yeah, I did change this procedure, because if it's in here, like, you've done a lot of changes, but in this one you see the signature, the API surface. So you can go like, oh, I did change this thing. I did add channels here, and you did change the audio sample, and you added channels to the audio buffer struct. You added this enum that has no comment on it, and then you changed how long the mix buffer is. And that's it. Those are the API changes. None of them are very big because very few people use this one, and few people talk about, like, if someone this one and this one, these changes, if someone generated audio from scratch, then this will break their code because it has gone from stereo to mono. But yeah, let's let me check something here in the what's it called? Coke maybe. Channel. Well, whatever, that one. Quite self-explanatory. Maybe I should comment this a bit more. All the samples of the audio buffer. This was it called here? This, in the case of stereo, I'm kind of repeating what it says below, but in the case of stereo sound, the left and right sample. Yeah, sure. Right. The number of samples per second. Note that the mixer uses 44,000 samples per second as defined by if this buffer when the sample rate of the buffer and the mixer do not match, then interpolation will happen. The buffer is mixed. Happen during mixing. So references. This is used. There's a ref counting thing going on here. The reason is that we have some kind of thing called audio instances. I will actually, that's the thing we're gonna revisit soon. So we're gonna not document that for now because I'm gonna revisit what that one does. Let's see if this pass the CI now. Yes. It did not. What was wrong then? Oh. Wait. There's because I haven't tested this on Mac because I changed. Right, let's go to the core audio. I did change I haven't actually updated this. This needs to happen. Core audio feed needs to be 2, and then there was a len there somewhere. Stop buffer. Len audio channels per frame. No, just put 2. It is always like that. It's not going to change. Why is this? Is it because it uses? I haven't written this code, but yeah, whatever. Let's leave it like that. Bits per channel, F42 times 8. Times 8. Bits per channel. Oh. Yeah, it's just bits. Yeah, it just expands 2 times 8. 42, right. Did you add an export function? It would be really cool to see an MP4 WAV. No, I don't. It's just for mixing in while you play the game right now, so it's no such thing. But maybe could do like some audio editing stuff, but yeah, I don't know. That should fix that. Mac error. Maybe. We'll see what the CI says. I'm just gonna probably merge this if it works. This is also probably broken in the ALSA backend because I didn't fix this, I realized. I just fixed it on Windows. Right, here we need a 2. Let's scroll up here. Yes, here it's a hard code. I'm promised that this 2 is the number of channels. Yes, it is. So stereo, so it's hard code. It's not going to change. Well, maybe it will if someone has. No. If someone has a, what's it called, a surround sound system, you know, they have like bass speaker, rear speaker. Those are very cool for 3D games, when you like have something blow up behind you and you hear it. However, in 2D games, usually what you do is, at most, you usually have left and right channels. Maybe you could make some 2D game that has surround sound support. Maybe. But I think it's quite uncommon, 2D games with surround sound. Maybe I'm wrong. But anyways, so since this is a 2D only library, I just don't support that, which makes things a lot simpler. So your sound sources can be mono or stereo, and your mixer format is always stereo. The end. It's like, you know, it becomes very unproblematic. Is that all I need to do in here? Let's see. Well, I'm looking at a diff. Looking at a diff with sound. Well, audio. Let's just look for audio sample. No, it's not all I need to do, because this is wrong. The data here is wrong. So right here, when is right used? I've written this code. This is my little ALSA, the Linux sound thingy. Hello, solver. Thank you for looking forward to trying my library. This, you know, the wave out and core audio stuff has its own internal processing thread that sort of, I think it has some synchronization and sort of does things on its own. ALSA actually doesn't have that. So if you, when you do this call in ALSA, when you just say PCM write, I think this one, then it blocks until it can write stuff, or it's until it needs to write stuff, or however it was. Which I noticed. Then I was like, wait, why is people were like, why do I have like super weird frame times on Linux suddenly? I was like, oops. So I had to add this thread procedure here that just writes the stuff, and it does, it uses I think it's called a lock-free circular buffer. It's actually quite. This is something I noticed about threading. In the case of, as this is gonna be some what's it called, some university level words used here. If you have a producer and consumer problem with a single producer and a single consumer, I don't know. But when you have that, so there's just one thing producing things and one thing's consuming them. Essentially, you feed the thread and there's only one thread, and they're not like, you know, there's no one-to-many relationship there. Then making a circle buffer is actually very simple, and I think people often overcomplicate this and they start using mutexes. You can do this without a mutex completely. What I do here is I have a buffer. It's reasonably sized, 5 chunk sizes, so that you can have a few frames. There's a comment here on why it needs to be exactly that one. And then where is the buffer start? That sort of, where has ALSA, what's the next place going to read from? When does it end? That's the last stuff we've written into it. And it's circular in the fashion that, you know, if it comes to the end, it just jumps back to the start. The end is a sort of end thing here, or the start thing here. It jumps back to the start. And then down here, when we feed samples into ALSA here, it will do an atomic load of the end. The overflow is if it went past the end. It just does some stuff to copy the correct stuff. So it copies the stuff that it needs to. Overflow is, oh yeah, then it just cuts. It takes slightly less and puts on, you know, if let's do some more paint. That was fun. Oh yeah. You know, if your buffer is like this, you need to write this much. Then it will just, this is the overflow, right? So if this is bigger than 0, then it will just write this part into here, and then it needs to take this stuff and write it over here, and then like that. So that's what this stuff does. You just use a slice copy, like it's just copying the stuff around using slice stuff here. So you see here it jumps back to the start of the buff end becomes the beginning again. Hello, Erival Junior O2Z, welcome. So it just adds on the end. You may notice that I don't have a check here if I go past the start. That's not really necessary because there's other code that checks so that it can actually never fill in more than like maybe 2 or 2.5 or 3.5, like some it says here. Maybe audio mix chunks types 3 should be enough. That's how much it could possibly fill in. But you know, I just took a bit extra. It doesn't really matter. I took times 5. So that's what's feeding it. And then it stores it back using atomic store. So the atomic is something that does it in one operation. So no thread can ever read something that's like half stored. And you can do that easily with something like an integer, an atomic store. So that's pretty neat. You just need, in many cases, you just need a thread and some atomics. And then when you read it later, here, start and end, you load the buff start and the buff end, right? You load those atomically. The end, we will never change. Let's see here, do we ever change the end? No, because the end is only changed by the thing that writes and stuff. This one is the only one that ever changed the start, which is where it has read stuff from. So we just say that, and there's a little thing here because sometimes the start is here and sometimes the start is here, but sometimes they are flipped because you might have gotten, you know, if your start is here and your end is here, start, end, that's quite usual. But it might also be that it's written stuff so that your start is here and your end is here, and then you need to start from here, and then you might, like, the start might be very close. The start might be very close to the so if the buffer sort of ends over here instead, then the start might be so close to it that it actually is supposed to eat some of this, jump around and eat some of this part as well. So that's why it does this. It's like if start is bigger than end, then it just eats everything from start to the end of the buffer, which is this missing thing here just means length of s.buff, essentially. And then it writes in the stuff to the end. Or if they're not in that way, then they can just take it in one go. Yeah. And then it stores the end back using atomics. And that so far has worked completely fine. No locks, no mutexes. Just one array and 2 atomics. Well, one array and some atomic stores. There's no atomic type here. That's quite nice also, that, you know, in some languages you need to wrap stuff in atomic types. These are just integers, but these atomic load, well, they're intrinsics, but are they? Yeah. They know how to operate on, for example, integers. So that works fine. Okay, let's see if this is fixed. I hope so. Because this thing will take s.buff. What is s.buff? This is not fixed. You see, I'm not on Linux right now, so I can't really test this. But I think if it compiles, then it will work. And I can test it later on Linux. This is supposed to be a 2. Maybe I should have like a audio stereo sample that is defined as 2 samples. But the reason I don't want that is that then you would expect it to be used everywhere, and in the buffers I just want a single type that is here are the samples, and then it has a separate thing that says, but how should we interpret them? Because otherwise I need to have like weird variations of those. So I prefer to just have this like that instead. Oh, let's just look through this. Audio sample, audio sample, audio sample, audio sample. Good. Now it should be fixed. Fix audio sample. Stereo audio sample. Fix for Linux. Yeah. Let's see. Now this one still didn't compile, did it? Ah, silly me. Web audio. That one I can test. Here we need a 2. Oh, this is the simplest backend. Well, it's not, but it looks simple. It's like, wow, is this all there is to web? You just feed on to some JS thing, and then you're like, wait, what is JS thing? Web audio feed, what is that? And you're like, and you go here and you're like, oh, what's this JS file? And then here I actually add the JS code to do this thing. So this proc here in Odin is bound to a JavaScript proc that runs in the when you do a WebAssembly build. It will run this stuff, and it does the audio stuff for the web. And this one I probably don't need to change. Yeah, I reinterpret it as, it's a bit silly. Here I reinterpret it as an array of F32s because it comes in as stereo samples, but then I didn't have a good way, I think, in the JavaScript to say that it was just an array of two-dimensional objects. I don't know. So I've put it back like that, but then maybe I just, yeah, it's sort of, maybe there's a better way to do all of this. Maybe it should be like, maybe there should be like a struct that is called audio samples, and it has an array of samples, and then it has all the information, what the sample rate is, what the channels is, but I don't need it currently, so let's just not do that. Let's see if this works on web. We go then to this thing, run task, and we say audio web, and we see what happens, if it explodes or not. It did not explode. So we go into Karl2D. Oh, wow, what happened? Karl2D. The pitch change. I don't know if you can hear that. Certain pitches is a slight tick 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 only on web. There, tick tick tick. Not sure what that is about. It's only if you change the pitch. Sure. Hi, just dropped in and might have missed it. Do you have a way to optimizing the buffer size, or do you just try out different buffer size in relation to the kilohertz? I have struggled before. Sample rate, I mean. I'm trying to interpret what you mean. I mean, I have sounds of different sample rates that I mix in. The mixer is always 44.1 kilohertz. Isn't it weird? It's not. People say that this is not. I'm not. People do this generally, and it's not about what you wrote. I mean, but people say kilohertz because it is samples per second. It's per, like, the unit hertz means 1/second. It's just a rate. But here, in this case, we have samples per second. So it's actually kilo samples per second. Kilohertz is kilo sample. But it's annoying to say. So I also tend to say, oh, it's 44.1 kilohertz. But I'm like, but it's... If you do the unit analysis, then you're missing the samples. But maybe sample is not a unit. I don't know. Yeah, me too. I mean, it gets a bit weird to talk about. Anyways, I'm not sure what you mean. Because optimize the buffer size. The size of the buffer is exactly what's needed for the samples. Like, if we look at, wait, let me just see if I can get this web stuff to well, I think compile it. It wasn't clicking. Maybe we can investigate that. Maybe that's fun. Web build fix. Yeah, now GitHub will do the CI, so we can look at load sound from bytes, for example. Here, this one is called when we load a wave file. So it comes in the raw audio data, and then which format is it, 8-bit, 16-bit, 32-bit, or a floating point, and then it comes in the sample rate. So it just converts them all to floating point, which is because I only want to work in one bit, what's it called, bit depth, or one format. So I want everything to be floats, but that doesn't matter for the sample rate. The buffer being small gives you little time if something goes out of sync, but it's better for latency. So I kind of struggle to find a sweet spot between the side and the side. Is this for like? Is this like for audio streams? Because I mean there's two things there. One is the mixer buffer, which is just a one-off, so that one you can have pretty big. And one is and there's several sizes here. One is this one. One is this one, the buffer I mix into, but that one is I just mix into it and then send that off to the back end, and it does whatever you want with it. But then, I also decide how many, I decide somehow how big the chunk size is. This is 1,400 samples per chunk. And then I need to decide at what rate should we mix in new stuff. So we have mix update audio mixer. This one says if we have more than 1.5 times the chunk size left, then we just don't do anything, because that will not produce, that will probably be fine. But if we have less than that, then we will mix in new stuff. So that's another, and there, I think this I might have to at some point make custom, because different backends have different latency. So this 1,400 number makes sense on Windows. But if I change on Windows, for example, from wave out to WAS API, whatever it's called, that one has lower latency, then I might be able to pick a lower number here, so that there's less delay from when you play the sound and when it comes out to your ears, less delay, but that will only work for some backend. So this number I might have to put it into the interface of the backend, so that it can say, hey, I want this mixer chunk size. So that's another number. And then it's of course the audio buffer has the samples, but for a sound this is all the samples. And they're not converted for the sample rate. These are, if they don't have the same sample rate as the mixer buffer, they get interpolated at mix time. So you have this in there. But then the special case is for audio streams, which is here. Audio streams read from disk, and they have a buffer handle here, which goes to a buffer. But in that case, that buffer is just a small buffer that it uses in a circular fashion to just fill stuff in that is played by the game. But it's just used as a bridge between, like, so that the thing that fetches things from disk has somewhere to put its stuff. So that it can get processed by the mixer. It's sort of, yeah. But I was quite pleased. Initially, I had two separate concepts. There was like one buffer for audio streams and one for the sounds. And I had to do two separate mixer paths for it. Then I realized, oh, I can just use a short audio buffer and just use it in a slightly different way for the audio stream. So, for example, when you're streaming a music file from disk. So that's pretty good. Let's see how this went. No, not that one. This one. There's a check. It's all good. Righty right. Let's just look through this. Maybe I'll just merge this. I think it's quite alright. This 2 here that's appeared everywhere, well, not everywhere, but in many places, I was a bit apprehensive about, but I think it's fine. Cause yeah. I mean the clicking on the web. I think that's been there since before. I don't think that's new. I think I heard it before. I need to look into that at some point. There is just something with. I mean, it is a bit weird that we don't hear the windows. Right? We don't hear the windows, do we? Let's just try. If we do, then maybe it's a real problem. Oh wait, it is there. Maybe slightly more subtle, but there is a slight clicking. So maybe I have messed up my interpolation code mix. Click. I think it worked okay before. Well, we can always try that. We can do like this. Git status, nothing. Git check out the master. And then we run it. See what happens. If we click. So it's not this PR. So then it's fine. We can merge it anyways. I don't know why I went back to that branch. I'm just gonna merge it. So that's a separate. We're gonna look at that. And like someone said, the Spying Wind said, pitch is tricky. Yes, it does create like you must sort of start interpolating audio, even when the sample rates match perfectly, and it's yeah. I might have done it completely wrong because I'm a bit naive in how I do these things. Here's this thing I talked about. It's good to do squash when you, for example, you've added a file that you've deleted again and maybe it's big. In this case, there was a wave file here. It's not visible here anymore because I deleted it. But if it's a big file and you added a big file during a PR, and then if you do the normal merge, if you use this one, then the whole history comes in and that file will be part of history and your repository will grow in size. But if you do a squash and merge and then delete the branch, then it's going to be fine. It's dangerous with Git and the growing repositories. It's nice to keep them small. Squash and merge. Let's just do this. And send audio streams. Make audio sample into a monosample. Make the backends use a 2 audio sample type. or you use the type to, for example, for stereo sounds. Simplified interpolation mixing procedure, the procedure that does the actual mixing used to be called add interpolate. With the addition of mono/stereo, it became too complicated, so now it's all merged into audio mix. So there we go. Let's see if that closed this issue. Yes, it did. There we go. So got the mono sound support in. Good. We're getting closer to merging to setting audio support is done. That's the beta free essentially. There are some items here that we still need to do. Streaming of music works, but it doesn't work on web because of two reasons. There's no way to stream on web currently, because you can't stream from disk because there is no disk, and just either I need to load the whole file and stream from memory, which is not really, you can argue if that's streaming, that you might as well use load the whole sound. But then there's also, I could maybe do that using some kind of fetch API wrapper, so it fetches. I guess that's how streaming works on the web, like on YouTube or something. Stream, but then also the Vorbis stuff didn't support, what's it called? WebAssembly. But you can that was added by Leighton yesterday, so maybe for the next we'll see. Maybe I don't know. I kind of want this library to work with the latest release, not the master Odin. You don't need to have a nightly or compiled from source. That's my wish. So I do have to wait 10 days with saying beta's audio is the audio beta is here, or we make it so that it requires a nightly. Maybe the nightly is fine, because I realize you don't need to compile from source, you just need to grab the nightly of Odin. Should mixing happen on a thread? It currently happens on the mixer runs on the same thread. I guess and you can't, maybe if we added some atomics for the setting of the target volume. Nah, because I think maybe you could do the mixing yourself on a thread if you want. You just call the mixer update on a thread. I might just have to add a thread or a compilation flag, threaded mixer. So you can turn it off, because in WebAssembly, for example, you probably don't want that because you don't have a thread. And it might not be, if you want to keep your game simple, it might not be required anyways, because the mixing doesn't take that long time. It's like waiting for it can take long time if you have a lot of sounds. We used to have hardware accelerated audio cards back in the day. We don't use those anymore because you can put it on a thread if you need to. So I have to consider that. Mol file formats than WAV. If I have all the Vorbis support, maybe I can add so you can load the Vorbis as a sound, and then also make it so that you can stream in a WAV file. I'm not sure what that should be good for though, because usually if it's that long sound, it's like why are you putting like a 30 megabyte wave file into your project. That sounds a bit weird. And the bus feature would be cool, so that you can like say that you can like create bus, and then you can say play this sound on this bus, and then before that bus is mixed into the mixer, you can say, hey, can I get all the samples for the bus for this frame? And then you can like mess with them to create audio effects procedurally for several audios at once. But that one I won't do in this. This one maybe I'll skip as well. This one I might skip. It's just the web stuff. I like when web things work. I don't think it's done until all my platforms work, and currently web is broken with. You can't play music on web. Well, you can play through a wave file. Like, oh, I'm gonna start my game now. We're gonna have to download 50 megabytes of wave file first. It's not so fun. So good, it's all in. Let's pull master here. Unocode asks, hey Karl, random question. What would be your approach to replicate the machinery style modularity and plugin system in Odin? Seems kinda inconvenient without header files, lol. So what this person is referring to is the machinery was a game engine I used to work on and used to have a popular blog. And we had a plugin system where you could compile DLL separately that you loaded later, and then since you had the header, you could use as the interface for what the DLL contained, sort of. So it was sort of like at runtime you can load a plugin or you can unload it, and then you can use the header as the sort of surface area. Odin doesn't have headers because Odin doesn't have headers. They are useful. They could be useful for two things. Like, you know, I have this doc file that sort of shows the overview of the file. That's a good use case for headers. But this I generate. So I don't think having headers is a good enough reason because you want better documentation. You can generate it from your APIs. So I do that for that part. But for headers for exposing the API surface of a plugin, you can do something similar, right? And I think I've done this. You're gonna have to see me dig through some stuff on Git here. Hold on. I think is it this one? KZG. I think this one has exactly what you're talking about. I was like thinking of doing a plugin based game engine. It's just a sketch. It doesn't, and it probably doesn't compile anymore. But what this thing does, it has a plugins folder. And for example, we have the renderer D3D12, and it looks like this. Here's my renderer, right? Cool. And then I have my own little API thingy here. I'll link this, by the way, so you can look at it. This might not compile. You can look at it if you want to. I think maybe there's a... Is there a... Wait, let's look at my newsletter. Maybe I had a... Oh, by the way, you can join my newsletter if you want. Link is also there. I think maybe... Yeah, yeah, this I wrote the whole blog. I wrote the whole newsletter, not a blog post, but my newsletter is sometimes a bit bloggy and sometimes not. I wrote about this problem, how to, when you have a plugin that's compiled as DLL, how do you expose the API surface of it, because Odin doesn't have headers. But since you have core Odin, which can parse Odin, then you can look through that stuff. You can look through your own code and output Odin files that are like headers. So what I did, for example, we have this file, right? This is my renderer in my old dead game engine project. And these are things with API in front. These will be copied straight into the API. API opaque means that it will copy this but without the content, so it will just be like state without. I think you can see this here, state just like this, like that one. That one is API opaque. These are API, right? And then on some procedures, I also put API, so that it says create API, and then those will end up in the struct called API. So that then you would like import. I think in the game, let's see what I did in the game code. Is this a game here, maybe? Karl2D, blah, blah, blah. Yeah, this is the renderer. And then, yeah, you see I create an API instance here from the state and API. I actually do sort of com style thing here, where I RD to the API buffer create and create shader and stuff. And the stuff, what that does is an API instance is just this. It has the API and the state and the stuff. But yeah, essentially what this this build plugins here does, which makes those DLLs, it takes those plugin files and it makes the API entry. But you're looking, you see here it looks for the attributes and it finds the API and API opaque, and it sort of processes them and adds them, blah 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 blah. You can look at this file and copy it and got it. Use it however you want. You see this file generates which compile. That's this. I think it's this file. It generates here. Yeah. You could do that. If you just want, like, if you want to make a modular game engine in this way, and then by all means do this. But you probably only want, like, the only caveat here is, I think, is you can do that if you want to actually create a project for other people to use that's supposed to be a modular game engine, or if you want to learn about it. If you just want to make a game yourself, then you probably shouldn't make it a modular game engine. Then you should just have like a file called D4D12 renderer, and in there you put your renderer, and you don't put it in a separate package at all, or something like that. But yeah. Anyways, I think it's time. I need to. I have plans for later today, so it's time for me to go. So the stream will end now. But thank you for joining my essentially fixing some things on a pull request and talking about a lot of things on the way stream. Have a nice day and bye bye.